Numerical models are able to tell you the ideal performance level and give something to compare against. They are models of sports performance based on numerical factors. There are three types of numerical models: literature-based, athlete-based, and combined approaches. Literature-based numerical models are based on information from journals, articles, key textbooks, coaching publications, and literature from websites. Athlete-based numerical models can be based around elite athletes or specific athletes by watching their performance and analysing different numerical factors within the performance. A combined approach takes elements of both using literature as well as observation from athletes' performance. The areas that influence numerical models are linear motion, angular motion, and projectile motion. Linear motion is where an object or person is moving at the same speed in the same direction. Angular motion usually incorporates linear motion within it, however, it also adds rotation and so is more relevant to a wider range of movements in sports. Projectile motion is more relevant to events such as high jump, where a person launches their body into the air, or sports such as javelin and shot put, where an object is thrown into the air. Kinetics are the branch of mechanics that deals with the actions of forces, whilst kinematics are the branch of mechanics that deals with motion or movement. Some of the issues of using numerical models are that the data collection methods can be poor, as well as the footage, which results in poor data analysis and potentially false conclusions. However, it is good as it can be accessible to all, as it can be done on a lower level with more simplistic equipment and software. It can also provide good evidence behind a person's performance and where they're going wrong. Scalars are a value that has magnitude, so how big, far or fast, but it has no direction, whereas vectors are values that have magnitude and direction, such as how fast something is going and the direction it's going in. So speed is how quickly a body moves, the rate of motion, and is measured in meters per second. Velocity is how quickly a body has moved in a resultant direction and is measured in meters per second with a direction, a plus or minus. The sign of velocity is always in the direction of the displacement. Velocity can tell you the axis, magnitude of the velocity, and the direction of travel. Zero velocity on a curve indicates that either a body is not moving or has changed direction. Acceleration is the rate of change, or speed or velocity, and is measured in meters per second squared. A change in the magnitude of velocity, direction of velocity, vector, or both. Positive acceleration is speeding up, negative acceleration is slowing down, and the area under the acceleration time curve represents the change in the velocity. Distance is the sum of all movements regardless of direction, whereas and is a scalar that tells us how much the body has moved, whereas displacement is a difference between an object's final position and its initial position, and it's dependent on direction. So if a body starts and ends at the same point, the displacement is zero. Displacement is a vector, so it has magnitude and direction. Displacement in one dimension allows you to extract three key pieces of information: the axis, magnitude of the change in position, and the direction of the change in position. So constant velocity is also can be translated as a constant speed. Zero velocity would be either standing still with no motion or changing direction. Acceleration is speeding up, deceleration is slowing down. So looking at the graph at the bottom, the acceleration slowly is the first section, and in a basketball situation, this could be going from stationary to gently running around the court to draw players out and create space. Accelerating quickly could be an example of a break, so sprinting down the court on the attack with the ball. The steady speed could be running around the court creating space. Again, slowing down could be decelerating after running down to the other end of the court in order to shoot. Stopping could be when the ball goes out of play, or slight pauses after someone scores. And speeding up in a different direction could be after a player scores and there is a slight pause, then the player has to run back to their own basket to defend. All bodies have an inertial value. This means that in order to change the motion of an object, the inertial value needs to be overcome. For example, someone running with the ball in rugby will have an inertial value. In order for someone to tackle them and stop them, they need to overcome their inertial force by applying a larger one. Inertia is a reluctance to change and must be overcome in order to change motion. Newton has three laws in regards to force. The first law is the law of inertia, inertia is reluctance to change, meaning a body at rest or moving at a constant velocity in a straight line will continue to do so unless it is acted upon by an external force exerted upon it. So inertia must be overcome in order for a change in motion to occur. The second law is the law of acceleration. This law states that the acceleration of a body is proportional to the force causing it, and the acceleration takes place in the direction in which the force acts. So in simple terms, this means that acceleration is proportional to the force that is acting upon the body. So if there's a small force, there'll be a small acceleration. The third law is the law of action and reaction. It states that to every action there is an equal and opposite reaction. So this means that for every force applied, there is an opposing force working against it at an equal size. There are three types of motion: linear, angular, and general. During linear motion, all parts of a system move in the same direction and at the same speed. There are two types of linear motion: rectilinear and curvilinear. Rectilinear motion is in a straight line, and the curvilinear is a curved line. With angular motion, a system moves in a circular path around an axis, so all parts move through the same angle in the same direction at the same time. General motion is a combination of both linear and angular motion, and because of this, it's the most common human movement. Linear motion can be caused by a direct force. A force is applied to the object directly through the body's centre of mass, where an eccentric force will create angular motion. It involves applying a force to one side of the object outside the centre of mass, which causes it to rotate. Impulse is another way of describing force. It's the force applied to an object for a certain amount of time and is calculated using force times time. So basically, impulse is concerned with the length of time a force is applied to an object or body, and it relates to the change in momentum that occurs as a consequence. For example, catching a ball in rounders, as you cushion the ball, more time as the force is acted upon for a longer time, so it doesn't hurt. Whereas if you try to catch the ball quickly, the force is applied over a short amount of time, and that causes it to hurt. Momentum is the amount of motion possessed by a moving object and is the product of mass and velocity. It can be calculated using mass times the change in velocity. The change in momentum is always equal to the impulse. This is closely linked with Newton's first law of inertia, that an object will keep moving unless an external force stops it, as momentum is basically the tendency for a moving object to keep moving once it's in motion. The type of force applied can have different effects. It can cause an object to transition from rest to motion, cause an object to change direction, accelerate, decelerate, or change shape. For example, a golf ball being struck by a golf club represents an object going from rest to motion, the object being the golf ball. In tennis, when a ball is hit towards the other player, when they hit the ball back to them, that is applying a force onto the ball to cause it to change direction. A force such as friction can cause deceleration, so kicking a football in long grass will mean that there is more friction, and so the ball will slow down. When a tennis ball is hit in tennis, the force applied onto the ball will actually cause the ball to change shape, but it's not always detectable by the human eye due to its speed. Stability relates to how difficult it is to disturb a body from a balanced position. There are a number of factors affecting how stable an object might be: the centre of mass and its location, base of support, and the line of gravity. Centre of mass is the point at which the body is balanced in all directions. It will vary depending on a person's position and their actual mass. So some people might have a more muscly upper body, and so their centre of mass will be higher up the trunk of the body. The base of support is the points of contact the body makes with the supporting surface, and so a larger base of support means that the body will be more stable. A person's line of gravity refers to the direction gravity acts on a body from the centre of mass. Gravity acts on the body, and the line of its direction essentially passes directly through the centre of mass towards the centre of the Earth. So as you can see, dependent on where the centre of mass is on the diagrams below, the arrow is always pointing down directly towards the centre of where the Earth would be. In order to increase stability, a person needs to alter each of these things. They need to lower their centre of mass. This can be done by physically getting lower to the ground, keeping the line of gravity between the base of support, and this can be done by keeping a wider stance of the legs, and additional points of contact will also help. This is why during the box out and rebound in basketball, the defenders will widen their stance and lower their centre of mass by bending their knees. It makes them more stable and harder to move out of the way and get around by the attacker. However, in certain situations, a person may want to intentionally decrease their stability. In sports such as diving and gymnastics, a performer will need to decrease their stability in order to perform certain moves or skills within their sport. Ways in which they can do this is by moving their centre of mass outside of their base of support, which is done by changing their body position. And this means that the line of gravity no longer falls within their base of support, creating instability. They'd also decrease their base of support and so will have less points of contact within the supporting surface. So as you can see in this diagram, she has less points of contact where it's only one foot touching the floor and her centre of mass has shifted to the right, and so that will drag her down and cause her to do a cartwheel. There are various methods of collecting data through numerical models for both the recording stages as well as the measuring stages. One way of recording data is through the use of 3D and 2D imaging. This works by using programs such as Vicon to record and produce 2D or 3D models of the person or object by tracking their movements. This can then be slowed down or sped up to easily track and analyse the forces that are being used during the movement. Similarly, digital images can be used to analyse the object. This is typically captured using a camera, taking bursts of images at once to track the change in movements. The still images can then be analysed later on. One of the things that needs to be taken into consideration when recording these things are the shutter speed and frame rate of the camera used. Frame rates is the number of individual frames that make up each second of video recorded, whereas shutter speed is the time that each frame is exposed for. The higher the shutter speed, the more focused and sharp the image is, and the higher the frame rate, the better it will be for producing slow motion videos. After having recorded the data, it's important to be able to measure the relevant information within the videos. Horizontal scaling and vertical reference involve holding a meter ruler in the frame at the start of the movement. This information is then input into the computer program, stating the size of the meter ruler in comparison to the rest of the frame, and this can then be used as a scale within the rest of the movement for the program to calculate the lengths of things within the movements. Perspective error is another factor that needs to be taken into account. Perspective error is about ensuring that the camera is perpendicular to the object at all time, and so to ensure this, the frame must be large enough for the complete action to be carried out. If the camera has to be turned at any point to capture the movement, or the angle from the object to the camera is altered, it will mean that different data will be calculated, and so it will no longer be reliable. Here is the data that was collected using a force plate to measure the amount of force exerted during the vertical jump, which we will come back to in 6.4 to analyse fully.